I was writing this essay for my teacher education class, and I cannot handle what's happening right now. This is supposed to be an essay analyzing a textbook, and I'm going to be a math teacher, so I'm analyzing this high school math textbook to see what are the pros and cons of using it, and how would this be in a classroom setting. And I was doing okay. I was working on the assignment, and then I got to this problem. And let me just pull up this problem because this problem sent me down such a rabbit hole. I typed up like 7 pages worth of essay that eventually I had to cut all of it because it had nothing to do with the main point of what I was writing. But this one problem is such a viscerally upsetting example of bad problem design, and it makes me really angry. So I need you to see this. It looks like an innocent enough problem, right? It's kind of cute. There's this bank account, and over time, as the days go by, the amount in the bank account is dwindling. You know, you're spending your money, you're having a good time, whatever. That's great. But the money is going down. And the question is, when is it going down the fastest? Which is like a totally reasonable question, right? Great question. And if I'm a new student who is figuring this out, my temptation would be to subtract. I would look at sort of each jump here. How is the bank account balance going down, right? Because, well, first we go from $350 to $285. So we're losing, what's that, $65? And then we go down and lose $75. And then we lose none. And then we lose, what is that, 35 more. So my temptation as a student would be to look at this decrease over time and say, look, from the second jump right here, this is where we lose the most money. We go down by $75. And like, as a student who's just learning this for the first time, that's a totally reasonable solution. That you look at it and you go, that seems like where it's decreasing the fastest. That seems like the answer to the problem. But of course, if you've been doing math for a while, you know that that's not actually the answer to the problem. And what I don't like about this is that it's kind of a trick. It's kind of a trap. Because what you need to notice is the fact that the days are not evenly spaced, right? In this first time period, you go from day 1 to day 6. So 5 days have passed, and you lose $65. But from this second jump, we go from day 6 to day 16. That means 10 days have passed, and we lost $75. And of course you would expect that if more time goes by, you're going to lose more money in that time. It doesn't mean you're losing money faster, it just means it was a longer period of time. And so actually, this $65 over 5 days is kind of worse than $75 over 10 days. So you would need to compute, okay, what's the decrease per day? And once you do that, then you can see that actually this first jump was the worst. Again, that's reasonable, but I don't like that this problem never points out to the student that they need to keep track of these days, right? I understand for an experienced student who already knows this content that maybe that's a useful thing to sort of check, are they paying attention? But for a new student who's learning, you can see this is problem number 1. This is the very first example of a rate of change problem in this entire chapter, and they give no explanation of what you're supposed to do. So if it were up to me, I would split this into 2 problems, where the first problem has day 1, day 2, day 3, day 4, day 5, and it's nice and simple, and then your purple strategy right here works great. You just check the decrease. And then I would write a little note, and I would say, hey, in the second problem, where it's the same problem but with different numbers, notice that some of the days are missing, right? That these day gaps are not the same, and you're going to need to take that into account. And if you just say that, now I'm not trying to trick you. If you're the student, I'm pointing out sort of the main purpose of the problem, but I'm not trying to trick you. So that was my first issue with this problem, and that already made me pretty mad. But there's actually a second issue with this problem. And the second issue is so bad that I actually had to lie to you. What you're looking at right now is not the original problem from the textbook. This is actually an improved version that I created. The original problem from the textbook is even worse. It's a very small change, but in the original problem, this was not $350, this was $550. That's the only difference. You can maybe see if we really zoom in that the 350 is a slightly different font because I edited it in there. In the original problem, it was 550. And that might seem insignificant, but if you take a look at this same problem, but we work it out using the $550 number, this is the original textbook problem, this is the catastrophic error that just blows my mind. If you use the wrong strategy that many students will use when they're first trying this problem, you get the right answer. So the problem encourages you to do it wrong by never pointing out that there's a little trick here. And then, if you get it wrong, if you do the problem incorrectly and you don't understand the math, you still get the right answer. You still say that this is where the most money was lost, where you were losing it the fastest. And so your teacher can't even tell that you did the problem wrong. So the student totally misses the point of the math. They don't even do any kind of rate of change, which is the entire point of this chapter. They don't notice that they did it wrong, and their teacher can't tell that they did it wrong, but they learned absolutely nothing. This is such a shocking flaw to me. Like, it blows my mind that this kind of thing, if you're a professional, like, math textbook author, that this kind of thing happens. It's like what was the thought process of the person writing this question? I don't know. Not trying to slam whoever wrote it. I'm sure they were busy and sleep deprived. It happens to the best of us. But I feel like if we're designing problems for students, we should be making them sort of diagnostically useful. There should be indications that sort of push the student in the right direction and get them thinking about the topics that they need to be thinking about. And for the teacher's sake, for their diagnostics, we need to make sure that the teacher can tell when a student is or is not understanding some math. So this made me very upset. I was pacing around my room in the dark. I had to get it out because it's just blowing my mind that this is a thing. Thank you for listening to my rant. Maybe you can tell why this didn't fit in my essay, but I had to get it out somewhere, so it's going out on YouTube, and this is what you get. I hope you have a great day, and a good life.